Good morning. My name is Matthew Driver, and I'll be doing a demonstration on OSPF. So as you can see, this is a topology. It's 3 local area networks. Each local area network has a PC or consists of a PC, a switch, and of course a router. They all have pre-configured IP addresses as well as their interfaces. So these routers are configured for OSPF. So this is an OSPF routing topology. So we can go ahead and show that. If you go into the actual router configurations, go ahead and hit enable, show running configurations. We can go ahead and show that it does have OSPF. So within my paper, I showed how to configure OSPF. You'll start off with router OSPF and choose your process ID number. I chose 100. And then of course you'll do your networks that are associated with your topology, which consists of your IP address, sub, and then your area number. And I just choose 0. You can do any number you want to. I just chose 0 to keep it simple. So as you can see, this is configured for OSPF. And that is also established for all your other routers. So the target, this is your malicious router. This malicious router has targeted this first local area network. So it's created a loopback. So any data that's been sent to this local area network, anything within this local area network, it will not go through because of the loopback created with this malicious router. He has hijacked the network. So every data that's going to here will come to here. And we can go ahead and demonstrate that. We go to PC2. Go ahead and start simulation mode first with ICMP packets. Go to command prompt. We're going to go ahead and ping the local area network 1 to demonstrate what happens. As you can see, we got a packet. We're going to go ahead and it's going to move through to the switch, to the router. And then what happens it's automatically sent or forwarded to your malicious router. And this will happen, as you can see, through all your packets that are being sent because this malicious router has infiltrated the network. And this is an unsecured network. So we can go ahead and show that, yes, it's being sent through all of them. Okay, let's go ahead and remove the simulation. And now we're going to go ahead and move to our secure network. So this is our secure network, same topology, same networks. And to know to confirm that it's actually secured, we're going to go ahead and move into our configurations, and we can show you that I have actually implemented authentication measurements to secure it. As you can see, we have our ISP or IP OSPF authentication, and then we have the key. So we're using MD5. This is an encryption right here. It was plain text, just a simple password. We encrypted it so that it's easier to nobody can see. So this is, as you can see, OSPF authentication. So what's going to happen? We're going to go ahead and test this again and see what actually happens. So we're going to go to our desktop. We're going to go to command. We'll first go to simulation. I'm going to go ahead and ping our local area network. Oh, I'll spell it right. All right. So as you can see, we're starting at our PC, moving through to our switch. Our switch is going to forward it to our router. I may have put in the wrong number. No. Yes, I put in the wrong number. It's not going to do anything. 1 second. So ping 192.168.1.10. So now we're going to see packets moving through to the switch, through to the router. And instead of taking this path, because these routers are all now talking together, they're authenticating together, it's going to forward it to the correct path. See, what I said in my paper is that utilizing your MD5 authentication or authentication in general, it takes a shared key, grabs that shared key, and it compares it with the MD5 algorithm, or it creates the MD5 algorithm. Then it's going to send it to the router. Now the next router is going to take that shared secret key throughout the network, and it's going to use the MD5 algorithm. And what's going to happen is, if it is correct, if they match up, then it's going to go ahead and forward it to its destination. If they do not match up, then it will drop the packets and it will consider it malicious. So this is OSPF authentication. If you have any questions, let me know, and thank you for watching.